This is the video for pre-lecture 2. So today we're going to be talking a little bit about some MATLAB basics. And so the first thing we have to produce in MATLAB are variables. And so variables are sort of these objects that MATLAB stores information and sort of gives it a name. So for instance here we have created a variable named x and we've assigned the value of 1. So the way MATLAB works is it's going to assume that when you have an equal sign in isolation, that you're assigning a value to something on the left-hand side. So for instance, if we had written instead of x equals to 1, we had written 1 equals to x, MATLAB would throw back an error, in part because 1 is not a variable, but also because x would probably be at that point undefined. So plug in x equals to 1, we don't put a semicolon at the end of the line, MATLAB will output our value here. Okay, so that creates a scalar value for x, so it's a single value. We can create a vector. In this case, we're creating a column vector. So inside square brackets, we can list the different values that would go into that column vector. So in this case, we've got y is equal to a column vector filled with values of 1, 2, 3. Next, we created a matrix A. So you can see that these semicolons effectively end the row and then move on to the next row. So if we hadn't had any semicolons, if we just had y is equal to 1, 2, 3, that would create a row vector. So for our matrix A, we're creating a 3 by 3 matrix where we're putting the values 1, 2, 3 on the diagonal. And so to do that, we fill the entire row. In this case, 1, 0, 0. We'll fill these 3 values, put a semicolon at the end of the line inside of our square bracket, and that will move us to the next row. If for whatever reason you accidentally call a variable, or if you haven't called or established the variable value, so in this case we haven't created a variable lowercase a, MATLAB is going to throw back this error for you to consider, unrecognized function or variable a. So this is a reminder to us when we're creating variable names. It's somewhat helpful to have the names be a little bit more descriptive than x, y, and a. So in some cases those are perfectly reasonable, but you may want to consider having a little bit more detail in the variable name itself. And you definitely want to avoid setting a variable name that's the equivalent of a function that's already built into MATLAB. So something like find or clear or sum, these would not be ideal variable names because they're existing functions. Okay, so within MATLAB, we're going to be writing a lot of commands, and so you can imagine we're going to do things like x plus 1, x plus 2, so on and so forth. And if we were to, for instance, have something where we wanted to take our value of x and just add consecutive numbers up to maybe 100, and our initial value was maybe like x equals to 0, you could write out 100 commands where you're just progressively adding them, or you could have this super long command where we're adding all these values, or we could do something where instead of doing these commands, so we're overwriting the value of x, and so we can see the pattern that develops here. We can use program flow control to more efficiently code something like this up. And so this would be a nice example where we're going to use a for loop. So we have 3 standard program flow controls that we're going to discuss today. The first is our for loop. So a for loop is a set of commands where our program flow control will run through those commands for a predetermined number of loops. So the standard syntax that we would use in MATLAB is going to say, okay, we have some counter. In this case, we're setting our counter value to I. You can set this to anything you want. You can set it to n. You can set this to t, whatever you're interested in. I find it's valuable to be sort of consistent with what we set our counter variable names to. And then we have a range of values. So we're going to have a range of values starting at first, whatever our first value is. So generally that's going to be either 0 or 1. We could move incrementally by units of 1, in which case we don't need the value of increment. And that's often going to be the case. In our class, there's not really a lot of cases where we need to skip values. But if we wanted to say, consider only the odd values, we could do 1, 3, 5, 7. So what you'd do there is you'd say, okay, my first value is 1, my increment is 2, and my final value, or my last value, would be 7. And then within the for loop, we're going to have a set of commands that we're going to execute. And so one thing that you should do, preferably, just to keep things a little bit more legible for you, is I like to have a tab to have all the commands that are within the for loop shifted over by one tab, and that just sort of gives us an idea of which commands are we blocking and looping through within our function. And so here what we have is, okay, an example where we're saying our initial value is x is equal to 0. So our first value is x is equal to 0. And then we're going to go into a for loop where we're starting at 1, moving at increments of 2, ending at 9. And so that's going to be our odd values between 1 and 9. And so what we're doing within our for loop is we're taking our value of x, we're adding our counter value, I, and updating the value of x. So the first time we go through, our value of I is 1, so it's going to be x, which is currently 0, plus 1 is equal to 1, so that's going to update our value to x is equal to 1. Next time through, our I value is 3, so that's going to update our x value to 4. Next time through is 5, so that's going to be 9. Next is 7, so that's going to be 16. And then finally we have 9, which will be x is equal to 25. So that's our standard for loop. We're going to do many examples with this, so I would encourage you to sort of practice with that a little bit, but we'll certainly be doing plenty of practice in class. The next type of flow control that we're going to be using regularly in the class is an if statement. So an if statement is not a loop. So what happens with a loop is you start at the for and you end at the end, and then you cycle back through sort of over and over. You keep returning and going through your commands until you've satisfied the number of predetermined loops that you're going to go through. For if statement, what happens is you start at the top and you work your way through to the end, and then you keep going. There's no returning back to the top of the if statement unless you're nesting that if statement inside a for loop. So what is an if statement? It runs certain commands if a condition is satisfied. So if we're starting at the top, what we do is we test, is our condition 1, whatever that may be, satisfied? If it's true, then we run commands 1. And then we jump to the end. If condition 1 is not met, then we check our next condition. Is condition 2 met? Yes. Okay, then we run commands 2, and then again we jump to the end. We don't run the additional commands if one of the conditions is satisfied. So in the case where condition 1 and condition 2 are not satisfied, that puts us in the else condition, which runs commands 3. You don't necessarily have to have an else if. You don't have to have a second condition. You also don't necessarily have to have an else set of commands. You could just simply say, okay, if something is satisfied, run commands 1, otherwise don't do anything. So let's take a look at the example we have below. What we're looking at here is we're saying, okay, x is equal to 2 initially. And so we have this function mod, which is short for modulo. And so basically this is a function that returns the remainder of something when it's divided by something else. So in this case we're saying, okay, is x divided by 2, what's the modulo, what's the remainder of that? If the remainder of that is 0, then that's our first condition. So in this case, x is equal to 2. 2 divided by 2 is 1. There is no remainder. So that condition is satisfied. The remainder would be 0. So what we're going to do is we're going to take our value of x and divide it by 2. And so in this case, that would just return a value of 1. There's no need to evaluate if our second condition is satisfied or our else statement is satisfied, so we would go to the end. If instead our x value was not equal to 2, but let's say it was equal to 3, well, we test our first condition. So x divided by 2 is 1 with a remainder of 1, so that does not satisfy our first condition. We go on to our second condition, say, okay, is the remainder 1? Yes, it is. So what we're going to do is we're going to take that value of x and double it. So our value would go from 3 to 6. Okay? If we had a value of 3.1, in this case, the remainder would be 1.1, so neither our first condition or our second condition are met. So we run our else statement, which outputs a display that says the value is not an integer, which is in fact the case. Okay, the final program flow control that we're going to consider is our while loop. And in this case, a while loop runs through commands for a runs through commands until a condition is satisfied. So in this case, we do have a loop, which we're evaluating a condition each time we go through that loop. And once that condition is no longer satisfied, once that condition is false, then we stop running through the loop. So for instance, we say, okay, I is equal to 0. Well, while I is less than 100, we're going to take that value of I and double it. Well, this poses a potential problem because when we double 0, it still is 0. And so that brings up an important point. While loops can stall code if the condition can't be met. So in this case, we're never going to have a value of I greater than 100 because it's always going to be 0. But let's say I was not 0, but it was 1, and we're going to take that value of 1. We check our while condition is 1 less than 100. That's true, so we're going to take that value of I and double it. So now we have a value of I equals to 2. Then we double it again because it's still less than 100, so that'll be 4, 8, 16, 32, 64. So 64 is still less than 100, so we're going to double it again to give us a value of 128. That's the first time our while statement is no longer satisfied, so we're not going to execute those codes, and so this will finish with a value of I is equal to 128, assuming we started with an initial value of 1. So we're going to run an example in class where you get an opportunity to use each of these program flow controls yourself.